This video was made as a guide. It does not replace training in any way. This is if you forget something or you need a quick review. Never do this or attempt to do this unless you've been properly trained by the proper person. Welcome to the NSL. Today we're going to go over spinning. The purpose of spinning a wafer, in this case for me, is I'm going to do some contact lithography, which is when you take a photo mask, which has a pattern on it, that's on glass. It has all chromium except the areas that I'm going to pattern onto my wafer or transfer onto this. So I need to coat this surface with a material that, when exposed to UV light, will actually be removed when I spray some developer on it. There are many reasons to spin up polymers, photoresists, HSQs, whether you're E-beam writing, UV exposing, doing lithography, or any other number of reasons. When you first enter the lab, if you know you're going to be spinning and no one's using it, you want to turn this on and let it warm up for about 5 minutes. That'll give you a more consistent spin speed time to time when you're spinning. We have spin chucks here. In this image right here, you can see we have a chuck that's made for a 4-inch wafer, a 3-inch wafer, a 2-inch wafer, and then that little one over there is for small pieces. We actually have a smaller chuck than that. That's almost like a pin chuck. That's for really, really small samples on the half of centimeter scale. It's very important that you never use a spin chuck that's larger than the wafer or the chip that you're going to spin. An example of that would be this 4-inch spin chuck with a 3-inch wafer. If you can actually see part of the spin chuck underneath the wafer, then you're using the wrong size and you need to downsize on the spin chuck, because it'll actually draw photoresist or whatever you're spinning down into this vacuum hole and into the system, which will actually hurt the tool. So I should show you, this is keyed right here. You can see it has a flat spot, and there's a flat spot on the chuck right here. It's the chuck holder that it goes onto. So it's pretty straightforward. So you want to test to make sure that the spin chuck is sealed so the vacuum will hold down the wafer. How do we do that? I just place my finger on top and press the pedal. And there's the alarm. That way, when you start spinning your substrate, it doesn't fly off and injure someone. After installing the spin chuck, you then want to place your wafer on top of it. And I'll do my best to get a rough centering on this by just kind of looking over it. You don't want to hang your head over it like this. You can get particles onto your sample. Give it a quick spin, and when you stop it, you can kind of see if it's off by what side sticks closer to the side of the spin ball. You kind of can just move it a little bit. Test it again, and that looks pretty good. When the wafer's centered as best as you can get it, then you want to adjust your spin speed. Today I'm going to be spinning at around 3K, which is generally the optimal setting for most resists. On this spinner, you'll notice we have a power switch, a spin speed knob, an accel adjustment knob, and then the timer. This can be set to minutes, seconds, microseconds. Generally, most spinning we do in this lab is for 1 minute. With the accel adjust, I always leave that at its lowest setting so it kind of ramps up and gives the resist a chance to spread out on the wafer. Now, I'm just using a Shipley product here, but like I said to start off with, you can use just about any material using the same techniques when you're spinning. What I like to do is squeeze the bulb outside the resist bottle, draw up a little bit more photoresist than you may actually need. Once the bulb expands all the way, then pull it up out of the liquid. If you do that before, then you're going to end up with all spacing in here, and you'll get bubbles in your resist, and it might give you not a very well spin. You could end up with bubbles in the resist when you spin. Take the first couple of drops of photoresist and squirt it into the spin ball. Next, right in the middle of the wafer. And I like to dispense just about right around about a quarter. Not a quarter of what's in the pipette, but about a quarter in size. Back over the edge, let it draw up slow as not to draw the resist up into the pipette bulb. I have seen some people, they'll take the resist and spray it all over the wafer in different spots. That doesn't tend to give a nice even distribution of the resist when you do that. This is the proper way to do it. Close up my resist and spin. While this is spinning, we have settings on the spinner here as far as how long it's going to spin for. Just about everything we spin in the lab, you spin for 60 seconds, but most everything here is 60 seconds long. After 60 seconds, the spinner will automatically stop. Then you want to remove your wafer. And as you can see, this wafer came out very nicely. It has one small comet on the outer edge there that generally won't affect anything that I'll be working on. And if I was spinning more than one wafer, I would take one of these quartz stands and stand it up facing away from the spinner and continue to spin and process as needed. At this point, it's now time to bake the photoresist. This particular resist gets baked for 3 minutes on the hot plate at 90 degrees or a half hour in the oven. So I know this is at the right temperature. This hot plate would place it down and then start our timer. I prefer oven baking my samples as opposed to hot plate baking. So what I would do is take this tool right here, which is made for picking up these quartz boats, lift it up and place it in the oven, which is set to 90 degrees. Open it up for 1/2 hour, and that's the Shipley manufacturer's instructions to bake the resist. While my wafer is baking in the oven, at that point, I would take the spin chuck off, take my dirty pipette and bring it over to the solvent waste station over there, clean this, dry it, throw it in the sharps container, and then I would take the spin bowl, placing a clean room wiper underneath it so we don't get photoresist all over the floor while we're traveling over there. Again, I would clean this with a little acetone, making sure it's cleaner than when I took it. After this is clean, we have a stack of spin bowls over there. There's one made for just about everything we spin in the lab. The stainless ones used for most photoresists. We have polymer ones over there that are used for HSQ, PMMA, stuff like that, but they're all labeled quite well. You don't want to cross-contaminate spin bowls. The stainless one is the only one we actually clean when we're done. The other polymers harden up, we scrape them out and get rid of that stuff as waste. 3 minutes later, coming back, remove the wafer off of the hot plate. If I'm done, they can go into the Floraware after letting it cool about a minute or so, if that. And that's basically spinning photoresist in a spinner.